Welcome back, Trig. We're going to be finishing up 5.2 and go over trig identities and cofunctions. So what is that going to look like today? We're going to go through bell work so we are adequately prepared for your homework quiz for 5.2a, basic trig functions. We're going to go over the objective, the essential question, how are trig identities really related to special angles. We're going to talk about that. Obviously, we're going to go through a couple of examples, 5.2b, trig identities. We're going to learn what cofunctions are. This is something that is brand new. Even if you're a part of my Algebra 2.2 class from last year, you did not learn cofunctions, so this is brand new to trig. We're going to go through the summary, closure. We're going to talk about your homework. Let's get to it. So these are the three questions that I have for you for bell work. Okay, I'll kind of move it up here so you can kind of see. So these are the questions that I have for you. Let's get started with the first one. Use the Pythagorean theorem to find the length of the missing side. Do I care about the angle? No, I just care about the length here. So my first step is going to be finding a. So a squared plus, what is b? That's 28 squared. And then c is going to be 35 squared. I'm not going to go through this because you should already know how to do Pythagorean theorem, but a will actually equal 21. A squared is 441, and then obviously you use square root, a will be 21. Okay, my second step is going to be finding my 6 trigonometric functions. So we're going to start with sine of theta. Again, I don't care about what theta is. That's not what we're finding. We're finding a. So sine of theta equals, if that is 21 right here, I'm going to do opposite. So that's 21. And then all over hypotenuse, which is 35. This, of course, reduces down to 3 all over 5. And so we start to notice that this is actually a 3, 4, 5 triangle. We can divide each one of these by 7. So that's what I'm going to do. I'm not going to keep doing 21 and 35 and 28. So divide by 7 is 5. Divide by 7 will be 3. And divide by 7 will be 4. So here's a 3, 4, 5 triangle. If you didn't notice that already, I'm telling you right now. So 3, 4, 5 triangle. This is cosine of theta. And so now cosine is adjacent over hypotenuse, so that's 4 over 5. And then tangent is going to be opposite over adjacent. So opposite is 3 over adjacent, which is 4. Now let's get to the other three reciprocals. This is going to be cosecant of theta. So this is going to be 5 all over 3. Secant of theta is going to be the reciprocal of cosine, so that's 5 all over 4. And then tangent of theta is, of course, 4 over 3. So this one was a really easy one. You will obviously see it on the homework quiz, but it is very simple. Don't forget to simplify. If you don't simplify, I'm inclined to give you some partial credit, but I'm not necessarily inclined. Let's just say do it right the first time. Simplify your answers. Please, please, please. Let's go to this one. This one is something that we did on the last video. It's actually very great. I love this question, but I'm going to go through it a little bit quicker. So tangent of pi over 3. Tangent of pi over 3 is just radical 3. So this equals radical 3 all over 2, because that's part of my problem, minus 1. And then this right here, in the last video at the end of the PowerPoint, we actually did the rationalized version of cosecant of pi over 3. We did the rationalized version of cosecant of pi over 3. I'm actually going to do the non-rationalized version. I'm going to show you how easy it is to use a non-rationalized version. The rationalized version that we did was 2 times radical 3 all over 3. The non-rationalized version is just going to be 2 divided by radical 3. Now, when I still have to multiply by the reciprocal, but if I say equals radical 3 all over 2, this, and then minus, when I multiply by the reciprocal here, I literally get radical 3 all over 2. Now, you should notice that this is clearly just going to be 0, which is fantastic. It's way easier. You don't need to re-rationalize anything. You don't need to deal with those big fractions like 2 radical 3 all over 3. It's just short, to the point, boom. Okay, so I just wanted to show you that because I'm sure some of you were thinking that. But I don't know if that one's going to be on the homework quiz at all. It may be on the honors, but it is actually very simple when you use the non-rationalized version. Let's use cosecant of 45. Try to do it without decimals. That means without a calculator, and that means the exact value. You can literally look at your notes, literally verbatim, and see what is cosine of 45 or cosine of pi over 4. Because remember, 45 degrees is pi all over 4 in radians. I'm going to use a triangle here. So if this is pi all over 4, this is my right angle. We said that this was radical 2. This is going to be 1, and that's going to be 1. So cosecant, the reciprocal cosecant is sine. So sine is opposite over hypotenuse, so 1 all over radical 2. Well, if I flip that then, because of cosecant, I just get radical 2 all over 1. Now, Math Excel will more than likely just want radical 2. If you put radical 2 there instead of, if you put radical 2 all over 1 instead of just radical 2, it will more than likely mark you wrong. But then you would just ask for partial credit, and of course I would give that to you. But that is my answer. Cosecant of 45 degrees, or cosecant pi over 4, is radical 2. Awesome. So that's my bell work. Let's get to the homework quiz. Pause if you need to. I'm going to move on. So the homework quiz, of course, is 5 questions, 20 minutes. Obviously, it's open notes. Please review your answers and send any partial credit requests to my email because, again, you guys can get extra credit. So let's just say you did do radical 2 all over 1. Obviously, Math Excel is going to count it wrong because they need this, but you put that. But this is a perfect example of which you can send to me an email saying as a subject line, hey, this is homework quiz 5.2a. I put this, it marked me wrong, but clearly it's that. Maybe you just put 2 and really it wanted radical 2. Okay? If you just put 2, of course it's going to mark it wrong, but maybe it's just a foresight, you're going fast, you forgot to put radical 2. Hey, I get it. I could give you some partial credit on that. Send me the email so that you can get that extra credit. If you don't send me an email, I'm going to submit your grade as it is. Okay, so please do that. It's for your benefit. Please, please, please. I'm the sole authority and the sole judge to whether or not I give you that partial credit, but it doesn't hurt to just send me the email. Okay? Awesome. So once you're done with the homework quiz, begin your Cornell notes 5.2b. Awesome. Let's get started. 5.2b, trig identities. I love this lesson. Trig identities and cofunctions. So how are trigonometric identities derived and related to special angles? We're going to find that out. You can hopefully, at the end of the lesson, utilize fundamental trig identities, cofunctions, by just solving particular trigonometric problems. Now, I love this meme. I had to put it on here. So, hey girl, what's your sign? It must be pi over 2 because you are the one. And then Sheldon from Big Bang Theory says, that's actually brilliant. Why is it brilliant? Because, of course, sine of pi over 2 equals 1. You can plug that into your TI-36X Pro. If you have yet to get your lovely TI-36X Pro from Walmart near you, it's $20. It's roughly $20. You should get it. It's awesome. It simplifies radicals and everything. Desmos does not simplify radicals, but this does. Get it, please. It's amazing if you can afford it, but you don't necessarily need it if you're really good at solving for radicals. And then, of course, we're going to learn about this. This is a quadrantal angle, sine of 90 degrees, sine of pi over 2 is 1. I love that. It must be pi over 2 because you're 1. You are the one. I have another awesome, cringy math pickup line that I'm going to show you later on in this video. And you're probably like, really? I'm like, yes, really. Really, really. Let's get to it. Now, what is an identity? An identity is just something that's always true. Okay, you are familiar, or you should be familiar with what we call algebraic identities. So this is an algebraic identity. It just means on both sides, it's always true. Okay, you can simplify both sides. A sum of cubes, you don't have to write this down, but if I have a plus b quantity cubed, this actually becomes a squared. Sorry. This actually becomes this. A plus b, and then times a squared minus a times b plus b squared. This is your actual sum of cubes identity. We don't ever call it identity. Also, you should know this, b squared minus 4ac all over 2a. This is what we call the, not the Pythagorean theorem. The quadratic formula. The Pythagorean theorem is also another identity. So I'm just giving you all these identities because we call them formulas or theorems, but honestly, they are what we call identities. Okay, so this side really equals that side. Okay, what are my reciprocal identities? My reciprocal identities are this. I'm not going to go through them. You can write them down. I'm just going to show you just very briefly why they make sense. Sine, the reciprocal of that is cosecant. Cosine is the reciprocal of that is secant. Tangent, reciprocal of that is cotangent. Cotangent, reciprocal of that is tangent, and so forth. Okay, so they do make sense. They are the reciprocal identities, and they're actually very, very easy to use. We're going to go through 2 examples in the next slide, and then we're going to go to another set of identities. Okay, so pause the video if you need to. Get these down. Let's get started. So let's go through this first example. This first example, sine of 41 degrees times cosecant of 41 degrees. I can set this up like this. This equals that. There we go. This can equal sine of 41 degrees times 1 all over sine of 41 degrees. Of course, this is all over 1. So what happens? Poofy. This equals 1. I could also set this up as 1 all over cosecant of 41 degrees times just cosecant of 41 degrees all over 1. Goes poofy, still equals 1. And it should still equal 1 because they are identities, and since they're identities, they're equal no matter how you do them on either side. Okay? Sweet. So that is the first example. Let's go to this example. Okay? Tangent pi, we can do radians instead of degrees. Tangent pi over 3 times cotangent pi over 3. So I can do tangent of pi over 3 times 1 all over tangent of pi over 3. Of course, the tangent of pi over 3's go poofy because that's over 1, and so I'm just equal to 1. Can I make that into cotangent and then leave that as cotangent? Could I make the tangent into cotangent, 1 all over cotangent of pi over 3, and make this into cotangent? Yes, I could, okay, just like I did here, but I'm not going to for the sake of time. So all you need to know is you can use these reciprocal identities, and of course, on the Math Excel homework, you'll see something like this. Let's move on. These are the quotient identities. I love these quotient identities. Again, if you were a part of my class from Algebra 2.2, you'll probably see or remember maybe these. They'll probably look familiar because we did go over them in Algebra 2.2. Okay? And so let's just say I have this example. Okay? Let's just say I have this example. What are they? Use the identities to find the exact value for the 4 remaining trig functions. Why is it 4? Because I have one right here and one right here. Now pay very close attention. I'm going to try to explain this to the best of my ability. Watch. This is sine of theta, yes? Yes. This is sine of theta, yes? Yes. What does sine of theta equal? Well, that equals 3 over 4. What does this sine of theta equal? 3 all over 4. So 3 all over 4. So that means what I can do is find my tangent of theta and say that this is 3 all over 4 divided by, just like my formula, divided by, what is cosine of theta? Cosine of theta is this. So I'm literally just substituting it in. That's all I'm doing, and that's all you need to do. Okay? So substitute that in. This is radical 7 all over 4. The 4's go poofy. That's the property of fractions. If I multiply by the reciprocal, they go poofy. And then I have 3 all over radical 7. I rationalize this to become radical 7 all over 3 radical 7 all over 7. So that's my tangent. Could I find the rest? Yes. So let's find cosecants. Cosecants are rather easy because I can just flip sine. So that equals 4 all over 3. That goes like that. Secant, I'm going to flip this. So this becomes 4 all over radical 7. I have to rationalize. So that's 4 radical 7 all over, not 4, all over 7. Boom. Okay. And then, of course, I can do cotangent of theta. Again, I don't care what theta is. I'm not solving for theta here. All I care about is solving for my angle measure, okay? That's all I care about. Sorry, my side length. All I care about is solving for my side length, not my angle measure. So I want to flip the non-rationalized version because it's easiest. I can flip that, but then I would have to re-rationalize, and I don't want to do that. So I want to use my non-rationalized version, and boom, there it is. Okay, so those are all three. 1, 2, 3, 4, 5, 6. All six. All six of them. And all four that I solved for. So these are the quotient identities. Could you use this one? Yeah, absolutely. If I wanted to use cotangent, guys, if I wanted to use cotangent, I could use cosine all over sine. So cosine I have, sine I have. So I could do radical 7 all over 4 divided by 3 all over 4. And then the 4's go poofy, and I still get radical 7 all over 3, which is exactly what I got there. I could have done that. I could have put those on top of each other, just like I did with tangent. It works out no matter what, which is awesome. Which is why trigonometry is so great. Okay, I'm going to erase this. If you have any questions, please email me about that. Okay, Pythagorean identities. The main Pythagorean identity that we're going to be using is this one. I'm going to actually show you how these are connected. They are very connected, but I'm not going to show you that right now. I'm going to show you that in the next slide. Okay, so how are they connected? I'm going to show you in the next slide, but right now, let's get to the example. Boom, this is what we do. This is what you'll see. And boom, this is what we will do. We'll notice that they give us the actual Pythagorean identity. Now, also notice that the squared is right here with the sine. So sine squared theta plus cosine squared theta. This is the same thing as saying sine theta squared plus cosine theta squared equals 1. This is not the same thing as saying sine theta squared plus cosine theta squared equals 1. This is not the same thing because here you're squaring the theta instead of squaring the function. I'm squaring the function right here, sine. I'm squaring the function cosine, okay? So make sure you understand the difference. I'm going to be using this right here and not this. So I'm going to actually erase this junk because I'm not going to be using that. Okay, now let's get to it. This is sine. This is sine. I'm going to literally put what sine equals into those parentheses. So watch, I'm going to put radical 2 all over 5 and then squared. Plus, what do I want to find? I want to find cosine squared theta. Okay, I'm going to go back to that formula and kind of do that variation. Equals 1. Okay, I don't want to find the rest of the trigonometric functions, although I could by using my other identities, but I'm not going to. I'm not going to show that, but you could absolutely. All we want to find is cosine. So now the square goes to the radical and to the denominator, so radical 2 squared is just 2. 5 squared is just 25 plus cosine squared theta equals 1. I subtract my fraction over, and this is literally always what students struggle with. They see, oh, it's a fraction. What do I do? It's a freaking fraction. You want to solve for the missing thing. The missing thing you want to solve for is cosine. It's just like as if you're solving for x. Okay? Just because it's a trig function doesn't mean anything. All right? Doesn't mean anything. Just because it's a trig function, it means nothing. Okay? So solve for the trig function. Subtract your fraction over to get minus 2 all over 25. This will become a different fraction. So this is all over 1 times 25 gives you 25 times 25 gives you 25. So what do I have left? I have cosine squared theta. This equals 25 minus 2 is 23. And then, of course, my common denominator is 25. Now, because this is squared, I do the inverse operation of squared, which is square root. Those go poofy. And I'm left with cosine of theta equals, now remember, this can be broken up into this, radical 23 all over radical 25, which reduces down to radical 23 all over 5. That is what cosine equals. Okay? I went through that pretty fast, but by all means, because I don't want this to be a long video, but by all means, if you have any questions on that, let me know. I can guarantee you this will be on your homework quiz tomorrow. I can guarantee you this question or something like it will be on your homework quiz tomorrow. So this is something that I would definitely make sure you know when you go on your homework. Make sure you have it in your notes so you can see exactly what I did. Okay? All right, let's erase. Now this one is another Pythagorean identity, but we're not going to be using this one. We're actually going to be using something similar, and I'm going to show you. We're going to be using this one. Now you may be thinking that does not look like this one at all, but wait. Watch. Can I take this formula, this identity, this equation, can I manipulate it into my favor? Because literally that's what mathematics is. You're just using mathematics all day long. You're manipulating it. Now watch. Can I make this into 1 equals secant squared theta minus tangent squared theta? Can I make it into this? And you should be saying, yes, you can. This equals this by definition, by math stuff, okay? So this equals this. Now, what does that mean for us? Now watch. This is 302. This is 302. That's secant squared, that's tangent squared. That's minus. Now watch. That's secant squared, that's tangent squared. That's minus. But this is theta. Watch. Is that theta right here? Is this theta the same thing as that theta? But in other words, is this theta the exact same theta here? Is this theta equal to that theta? You should be saying yes, of course, yes. Okay. So whatever this number is, that number must also be. Okay, so it's not like this number can be 10 and that number's 15, or that number's 100 and that number's 5. Okay, if this is 100, this is 100. If this is 10, this is 10. If this is 302, that's 302. And if this is 302 and if that's 302, what does it equal? It equals 1. Okay, and so you can solve this, yes, using a calculator, obviously, but you don't need to use a calculator because you can use your wonderful identities, okay? And it's really that simple. It doesn't look simple, yes, I get it, and I know you're learning it for the first time, but honestly, guys, it really is that simple. Okay, let's erase that, and let's move on to the proof. If you don't want to see the proof, by all means, just skip past this, okay? Kind of go a little bit more minutes forward. Okay, I'm going to show you the proof because I think it's amazing, okay? But I'm going to show you the proof very, very fast, okay? So we start, first of all, with our Pythagorean theorem, of course, okay? Because it's the Pythagorean identity. So we start with the Pythagorean theorem. So this Pythagorean theorem, now that we started with the Pythagorean theorem, what if I divided, just what if, I divided everything by c squared? What would I get? Well, I get this, a squared all over c squared plus b squared all over c squared equals 1. Now watch, can't this change into a all over c squared plus b all over c squared equals 1? You should be saying, yes, it can. Now watch this. I have this triangle here, right? Watch. What is the opposite of theta? It's a. What is the hypotenuse of theta? It's c. Opposite over hypotenuse is sine, right? A over c, right? What is this? That is a over c. We just said it was sine, right? So this actually equals sine of theta squared. Now what is b over c? B over c is the adjacent side and then the hypotenuse, right? That's cosine. So b all over c of this theta is actually cosine squared and then equals 1, which of course reduces down to sine squared theta plus cosine squared theta equals 1. This is my Pythagorean identity. Now, in order to get the other ones, all you would have to do is literally just divide both sides by each leg. So this sine squared theta is a leg. So if I divide it by sine squared theta, I get 1. And then cosine all over sine, if I divide it by this sine, cosine all over sine by my quotient identity is tangent squared theta. And then 1 all over sine by my reciprocal identity. is cosecant squared theta. And then if I did the other side, it would be tangent squared theta, and then plus 1 equals secant squared theta. And this, of course, is my last identity. So they are related. They are all related. And it's so cool to see how the math works, that people have actually proven this stuff. And so, again, this is just for free. You're not going to be quizzed on this at all, but I think it's cool to actually see where the math comes from, not just why it works, how it works, and what it is, but to actually see where it comes from. That's the awesome power of of just advanced mathematics. Okay, let's erase. Again, that was for free. I hope you enjoyed it. Let's go through these checkpoints. I'm going to pause the video. You should pause the video, and so kind of do them. See if you understand them yourself. I'm not going to go through them very briefly. I'm just going to really quickly go through the answers, but I'll have the work up there so you can see the work if you need to. So please go ahead, pause the video, see if you need to work out any kinks on these problems on trigonometric identities, okay? All right, welcome back. So these are the answers for checkpoint 5. I have cosecant equals 3 over 2. Secant, I have 3 times radical 5 all over 5. I have to make sure I rationalize. I get those by just switching these, the reciprocal, because those are the reciprocals. So I wanted to cancel those out first. Then I went for tangent. I did sine all over cosine because that is my quotient identity. So tangent is sine of theta all over cosine of theta. That's my quotient identity. So I applied it here, 2 all over 3 divided by radical 5 all over 3. And then the 3's go poofy. It gives me 2 all over radical 5. I rationalize to get this. And then, of course, the cotangent, I take my unrationalized answer from tangent and I flip it. For checkpoint 6, I need to use my Pythagorean identity, the sine squared theta plus cosine squared theta equals 1. And then, of course, I have the 1/2 squared, because I put the 1/2, the sine of theta equals 1/2. I put the 1/2 in for sine. So 1/2 quantity squared plus cosine squared theta equals 1. I start going to town, simplifying, and of course, I get to this part. I have to do the square root. It's the inverse operation of squared. So I want to get rid of that cosine squared, so I just have cosine. And then now I can simplify from radical 3 all over radical 4 to be radical 3 all over 2. Okay? Awesome. Because I think it's funny, I'm going to just pause here and tell you the joke, or the pickup line. This Pythagorean theorem, now that you're actually using the Pythagorean theorem identity, it's awesome. And I had a girlfriend in high school, and I basically used this pickup line on her. And she knew what it was because she was in pre-calc 2, and she just looked at me like, "You're for real? You're using this right now?" I had a teacher named Mr. Hazelhorse in my pre-calc class for my 12th grade year of high school. And he told me about this pickup line that told the whole class. So I'm going to carry on the tradition and tell you. So sine squared theta plus cosine squared theta equals 1. Here it is. You must be sine squared theta. I am cosine squared theta because together we're 1. Yeah, girl. Okay. If you're cringing like, yes, I get it. Like it's not really, it's pretty cringy, but hey, I was with her for like almost 3 years, so it must have been something worthwhile, right? So I told my wife that, and she had no idea what it meant. So obviously, she didn't take pre-calc. Let's erase. I thought that was pretty fun. Okay, enough with the stories. Let's go to cofunctions. Cofunctions is a new thing that's completely just for trigonometry. I'm going to explain this really quick. It's really, cofunctions are actually very, very simple to know, guys. It's really just taking the cofunction, the complementary angle of the triangle. So let's just say this, guys. Let's just say this theta was 60 degrees. Of course we know, because of special right angles, we know that this is now 30. But what if we didn't know? Could we take 180 minus 60 degrees minus 90, and does this equal 30? Obviously it does. But wait. What if we know that this is 90 degrees, couldn't we just take 90 degrees minus 60 degrees, my other angle here, my other angle, and then does that equal 30 degrees? Yes. Okay, so this maybe brings back some geometry stuff because it really is. I mean, it really is a geometric formula, but I'm going to use that formula and I'm going to implant it into what we call these identities here. Okay, so what are my identities? You only really need to write down this stuff. Okay, honestly, we only use them a couple of times. We don't use them a lot. The quotient identity, the reciprocal identities, and the Pythagorean identities, we use a lot more, let me tell you. We use a lot more, especially in the next coming weeks, but we don't use these as much, okay? Math Excel will ask you to be using them. Just use them because it's actually very simple. I'm going to show you just 2 examples on them. Now notice, remember, everyone needs a co-captain, but here, sine, you would be thinking the co-captain of it is a cosecant, but this is actually cosine because there's a difference between a co-captain and a co-function. Okay, its co-function is cosine because again, in the Latin, the Greek, it basically means sine basically means angle, and cosine means co-angle, co-function, right? So this is my formula. If I don't have degrees, I'm going to replace 90 degrees with radians pi over 2, because pi over 2 radians is the same thing as 90 degrees. Okay, these are actually not too bad of formulas. They're a lot easier, I think, to work with because you're not really solving anything. You're just kind of finding co-functions, complementary angles with what you're given. So what does that mean? Let's erase. Let's find out. Okay, so I'm given this. Okay, sine of 72. What is a complementary angle or co-function angle of sine of 72? Well, I can write sine of 72 degrees equals the co-function of sine is cosine, and then I take 90 degrees minus, and then I add in what I was given, the 72 degrees. Okay, and this, of course, equals cosine of 18 degrees, and then I'm done. That's literally it. That's it. And you're like, really? We don't need to solve it? Well, you don't know what sine or cosine of 18 degrees is. It's definitely a decimal. It's really difficult to find the exact value here. Okay, we will eventually learn the exact value, but not today. So yes, it's that easy. You're done. All you want to find is a co-function. You're not finding the side length, the side angle. You're not evaluating anything. You're just finding the function, and it is that. Okay. Now the co-function of cosine of 18 is sine of 72. If you wanted to do, what's the co-function of that? It's sine and then 90 degrees minus 18. Of course, this is sine of 72 degrees. Okay. So this is the exact same thing. You can flip-flop back and forth. So the co-function of sine of 72 is always, no matter what, the cosine of 18 degrees. Okay? That's why it's called an identity. Now, if you have cosecant, its co-function is actually secant. So I'm going to take pi over 2 here and then minus pi over 3. Notice I'm doing radians now instead of degrees. And of course, this is 90 degrees minus pi over 3 is just 60 degrees. So 90 degrees minus 60 degrees is 30. And 30 degrees as radians is pi over 6. So that means this is secant of pi all over 6. Now, if you're like, whoa, what did you do? If you wanted to actually do the fractions, you can. So I'm going to do the fractions. Times 3 gives me 6. Times 3 gives me 3. Times 2 gives me 6. Times 2 gives me that. 3 minus 2 is just pi all over 6. It's the exact same thing here. That's a fractional arithmetic here. Just finding common denominators. That's all I did. Okay, and then this is the actual just kind of abstractly thinking, okay, that's 90 degrees minus 60 degrees is 30 degrees. 30 degrees in radians is pi over 6. And I keep the secant there. Okay, so I went through those really fast. Replay if you need to. Again, they're not that complicated. You're just finding the actual co-function angle. Now, you could, right here at least, you could find secant of pi over 6, by the way. And sometimes Math Excel may ask you that because this is a special angle and you do know that exact value. This is the reciprocal of secant is cosine. So cosine of pi over 6 is actually radical 3 all over 2. And so the flip of this, the rationalized version of this, is this right here. Okay, this is the rationalized version, the reciprocal of it. So if I flip this and then I rationalize the flip, I get this. So if they wanted you to actually evaluate secant of pi over 6, it is 2 times radical 3 all over 3. Okay, but you can just look at straight up your notes from yesterday and be able to find that and answer that. But you can't answer cosine of 18. You don't know what that is. You don't know the exact value of that. It's just a decimal. Okay, but you do know the exact value of that because it's a special angle. So let's erase. That's basically cofunctions, guys. Okay, and that's just, essentially what I just explained, the actual solution. Now let's get to practice. I'm going to show you these two examples. Go through them, see if you can use a reciprocal, a quotient, a Pythagorean identity, a cofunction identity. Use whatever identity is necessary, okay? Use whatever identity is necessary, and then solve these questions. We're almost done, guys. Go ahead, pause the video, see if you can check yourself. All right, guys, welcome back. So these are the answers. So hopefully you got these. The first one, I want to use a cofunction identity. They're so kind enough to actually tell you to use a cofunction. So cofunction identity, the cofunction of cosine is, of course, sine. It's not the co-captain. The co-captain of cosine is secant, okay? But the cofunction of cosine is sine. So I'm going to use that. I use pi over 2 in here in blue and minus my actual angle, 3 pi over 7. I need to find common denominators, and that common denominator is 14. So times 7 here gives me 14, times the numerator gives me 7, times 2 down here gives me 14, 3 times 2 gives me 6, 7 minus 6 is just 1 here, which I didn't write, but you can, and then 14, and then minus 14, you get the same denominator, 14. So what I have is just pi all over 14 and sine. Okay, so make sure you include the sign. Make sure you include the function, sine of pi over 14. Now this one is actually really easy. They say using an identity, it's just the Pythagorean identity. I noticed that these thetas are the same. These are the same angle measure, pi over 10, pi over 10. And if that's squared and that's squared, that means it is sine squared theta plus cosine squared theta equals 1. If you're sine squared theta, I'm cosine squared theta. Together, we can be 1, girl. Right? Yes? Okay. If that helps you remember, then awesome. So that means it equals 1. All right, and I don't need to solve it any more than that. Awesome. So let's erase. I hope you guys got the correct answers there. Now let's get to actual calculator work. I'm going to show you how to use the calculator. By calculator, I hope you have the lovely TI-36X Pro available at your local Walmart. Usually, okay, it's about $20. Really easy. You can plug all of this stuff in here, but because it's so tiny, I'm actually not going to show you how to do it on the TI-36X Pro. I'm going to show you how to do it on Desmos. Okay, so don't hate me. Okay, awesome. First things first, how do you put trig functions in the calculator? You need to check to see if it's radian or degree mode. Okay, if you're on the TI-36X Pro, just click on and then just click on the mode. So the button should be like right here, right by the second button. And then you're going to click on mode. And then the first thing you should see, if you see it right here, is it's blinking degrees. And then right next to it, you can scroll over to radians. That's how you change it for the TI-36X Pro. Now, to change degrees and radians for Desmos, if you go to Desmos right here, you see a lovely menu popping up right here. So if you do this menu, it's going to be the graph settings, and you'll see it's radians and degrees. It will automatically default to radians. You have to change it to degrees if you want to change it to degrees, if it's asking you for degrees. So make sure you just know that. If you open up a brand new Desmos tab, like I usually do, then it's automatically going to default to radians. But the problem is I want degrees because right here it's asking for degrees. You know it's degrees if they tell you it's a degree symbol. If they give you a degree symbol, it's degrees. If they don't give you a degree symbol, it's automatically radians. So how do I evaluate sine of 53? How do I evaluate sine of 53? We go to desmos.com and we literally type in sine and then 5.3. Yes, it is that simple, I promise you. And then that is my answer. I want to round to the 4th decimal place, so I'm going to round right, cut it off right there. So 0.7986. I'm actually going to stay on this screen, guys. So this is what I'm going to do. I'm going to go back to the PowerPoint. Wow. I'm going to go back to the PowerPoint. I'm actually going to show you all the problems we're going to go through because there's a lot. And I'm actually going to just allow you to pause it so that you can actually copy down everything. And then I'm going to come back here and I'm just going to stay on this screen. So I'm not flipping back and forth. Okay. So again, I'm going to go back to my PowerPoint like I am now. Okay. I'm going to show you all this. This first answer we got was 0.7986. We were in degree mode. So this is my answer. This is my side length answer. Okay, it gives me whatchamacallit. Gives me a decimal. Go ahead and copy the rest down. I'm going to give you some time to copy the rest down, and I'm just going to stay on Desmos and just boom, 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 hash all these out because it's way easier for me instead of flipping back and forth. Copy them down. I'm going to go to Desmos, and we're just going to hash them out, okay? All right. So what's the next one? The next one was cosine, and then parentheses. You don't have to use parentheses, although I would strongly suggest you use parentheses. So that was my next one. So I'm just literally typing it in. Boom, that's it. My next one was going to be tangent. So tangent of 76 degrees, and that's what I have. I'm just going to hit enter. So these are all my answers. And most of the time, Math Excel will ask you to round to the 4th decimal place. So this 2 becomes a 3. I'm going to actually blow it up here. So 0.7373. So that's that answer. And then this becomes 4.0108. Okay, so those are the rounded answers right here. Let's go on to the next examples. It's going to be in radians now. So the first one that we see in the next column is sine of pi. I'm going to use parentheses here. Pi, I just type in pi, and it automatically registers as pi. I'm going to hit my divide button on my keyboard, and it goes down into the denominator, and then 3. And I can close parentheses if I want. But hey, notice this is still in degree mode, so I must change back into radians. And yes, you will. I will have multiple people make that mistake. And no, I'm not going to give you partial credit. If you tell me, oh, I was in radian mode instead of degree mode, can I get partial credit? No. Okay, I'm not going to give you partial credit. This is something you must do because it's wrong. Okay, it's straight up wrong. Okay, it's not even like a decimal off. If you rounded wrong, yes, I will give you partial credit on that. But if it's just straight wrong, even though you were in a different mode, I'm not giving you partial credit on that, okay? So make sure you're in the proper mode. So this is my answer here. Okay, make sure you round to the 4th decimal place. Let's continue on. Let's do cosine of pi divided by 6. Now notice when I don't put it in parentheses, what happens here? It does this, right? So that means I need to use parentheses pi divided by 6 because they're totally different things. Obviously, because I get something different, right? Now watch this. I know cosine of pi over 6. We know that exact value. That exact value is radical 3 all over 2. Sine of pi over 3 is radical 3 all over 2, okay? Because we learned that yesterday. Now, if I do radical square root, all I did was type in SQRT and automatically did square root 3. I go outside of it and then divide by 2. Notice they're all the same exact thing. So you can use that to double check it as well, okay? Sweet. Okay, let's go to my next one. My next one is tangent, parentheses, 5 pi divided by 12, and I get that. So go ahead and round to that. It's really easy, guys. I mean, seriously, like it's that easy. I'm not even lying to you. All right, now let's go to my next example, secant. Now the cool thing about Desmos is I can actually type secant of 48 degrees. Okay. On the TI-36X Pro, pay very close attention. If you're using the TI-36X Pro, you will notice it does not give you secant. Instead, what it does give you is something that looks like this, cosine to the -1 power. Okay? This does not equal secant. Okay? It does not equal secant. Don't you dare do that. This right here means the inverse of cosine. Secant is not the inverse of cosine. It is the reciprocal. Okay? They're different things. Reciprocal is not the inverse. Okay? So do not use this on your TI-36X Pro. If you're on the TI-36X Pro, you need to type it in like this. Ready? So I'm going to scroll down. I'm going to actually get rid of some of these so you can use it. On the TI-36X Pro, you need to type it in like this, guys. Let me erase this. You need to type it in like this. 1 divided by cosine of 48 degrees. Now notice these are the same. But also notice I'm not in degrees. So I need to change it in degrees. Okay, so these are the exact same. Notice how this is the same thing as this one. So on the TI-36X Pro, you need to type it in like this, TI-36X Pro. Okay, you don't have an actual function like this as Desmos does. Desmos does have the actual function. In fact, I'll show you where it is. Okay, so if you go right here, and then you go to functions, and then trig, you'll see that here are the 6 trig functions just labeled right here. Notice how they actually have secant, cosecant, cotangent. Your TI-36X Pro does not have that. You have to do the reciprocal of it. Okay? That is a huge distinction. Make sure you know that. If you want to just use Desmos and type that in, that's perfectly fine. That's usually what I do. But if you're using the TI-36X Pro or even a TI-84, if you're using a TI-84, you also need to do that. Or if you use another outdated calculator like one student here, that's like literally 20 years old, it's literally scientific calculator, then yes, you probably need a better calculator. But yes, you would have to do the same thing, 1 all over cosine 48. Okay, let's finish it out here. Cosecant, and then I have 3 pi divided by 10. Now this is in radians, so I need to go over here. I need to make sure I'm in radian mode. So that is my correct answer there. Okay, that's my correct answer there. And now, wow, it has a little box there. Isn't that cute? My last one is going to be cotangent of 60 degrees. Now, since it's 60 degrees, I need to make sure I go over here and change it back to degrees. And so that is my answer. Okay, so just switching back between radians and degrees is really the thing that you guys need to understand here. So let me erase. Let me go back, make sure you get all those answers down. And boom. All right, so I hope you guys are keeping calm. You're not exploding. I hope it's pretty much you understand everything with the identities and the cofunctions. If not, just please email me. But what did we learn today? We learned how to first recognize and use fundamental identities, trigonometric identities. We learned the reciprocal, the quotient, the Pythagorean, and the cofunctions. We used equal cofunctions of complements to solve for just what is the cofunction, not really the angle, but not the actual side length, but we solved for what the function actually is. And when we had formulas for that, that's an identity. And then we also evaluated trigonometric functions with a calculator. We learned how to switch between radians and degrees and the importance between using Desmos and the TI-36X Pro. So that was a summary. Awesome. Your homework quiz is tomorrow. Remember, if you forgot to take the quiz last week, the radians and arcs quiz, you can actually do that. You can retake it this week. You just need to email me. Or if you didn't like your grade, you can absolutely email me. That will hopefully be due this Friday, but no later than this Friday. So please email me if you need to retake that. Homework quiz, do your homework tonight. 5.2b, trig identities and cofunctions. Please, 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 if you have any questions, let me know. Guys, again, it's been real. Peace out, Trig.